Okay, a few of you had emailed me questions about some of the homework problems on a comparison test and a limit comparison test. So I just wanted to run through a few of them here, and I'll point out again, just like I pointed out on your homework when I was grading it. Remember, you can't just say something is convergent or divergent. You have to actually show the test that you performed, do the test correctly, and then draw a conclusion from that. If you just write convergent or divergent, that means nothing. In an exam, you're going to get all of them wrong. Because I'm not testing whether you get convergence or divergence, because that's a 1 and 2 shot. You can just guess. What I actually care about is the test performed correctly and then getting the correct conclusion and going from there. So for this was section 4.3, and there were 3 problems people asked about. First, number 5, n equals 2 to infinity of n to the 4th over n to the 5th plus 1. And as far as it goes, to a certain extent, as I've said in some of the videos, and we'll keep on saying, the ultimate goal here is kind of an understanding of numbers and how they work and how they grow. And we can actually go back to what we did in pre-calc. That's a polynomial on top, that's a polynomial on bottom. Ultimately, that's a 4th degree on top, that's a 5th degree on bottom. So what would dominate here? The 4th degree here, the 5th degree here. Which means ultimately, if I kind of simplify this down, it's really just a 4th degree polynomial over a 5th degree polynomial. The leading terms, the highest powers will dominate, but that's really just 1 over n. Which means when I look at this, my brain should kind of tell me, okay, I think that one's probably going to diverge, because ultimately, no matter how messed up it looks like 1 over n, which we know diverges. Now, and again, here's where I say, you can't just say, oh, it diverges, because it's kind of like that. You have to then perform a test and mathematically show that it's divergent. And in this case, we can either use the comparison test or the limit comparison test, but let's see. If I want to use the comparison test, and I assume this is divergent, then I need to find a series that is smaller than it that also diverges. And if we had a fraction, generally the way we make a fraction smaller is to make the denominator bigger. And the problem here is, in order to make the denominator bigger, I would have to add to the denominator. But that doesn't really help me, because it's really the plus 1 that's making this messed up. In order to get rid of that, I'd have to subtract it, which wouldn't make the denominator bigger. And there's a point here. That means the comparison test isn't the test I want to do. I can't just say, oh, drop the 1, it's 1 over n, and I'm done. That would fail the comparison test. So we'll go with the limit comparison test, and again, the way this actually works, see what dominates on top, see what dominates on bottom, simplify it down. Now I know that one is divergent, and that will be the one I use for my limit comparison test. So now, I take the limit as n approaches infinity of this one, n to the 4th over n to the 5th plus 1 over that one. Simplify it out a little bit. This n goes to the top, that goes to the bottom. I get n to the 4th times n, which is n to the 5th, over n to the 5th plus 1. Now I take the limit. And in this case, it should be obvious, going back to pre-calc, the limit here is going to be 1, the horizontal asymptote, the degrees are the same. If you wanted to show this, there's 2 ways to show it. One, take the limit, and I could convert these to x's and apply L'Hopital and do all of that. Or in this case, the other trick you learned to take limits in Calc 1, divide by the highest power of n, which is n to the 5th. So I get n to the 5th over n to the 5th, n to the 5th over n to the 5th, plus 1 over n to the 5th. That, again, that trick from Calc 1, take the highest power of n or x, or whatever you're taking the limit of, and divide every term by it. Then you get 1 over 1 plus 1 over n to the 5th. As n approaches infinity, 1 over n to the 5th approaches 0. And I get 1 over 1, which is 1. and then my limit is equal to 1, which is finite and greater than 0, which means whatever is true of one is true of the other. Either they both converge or they both diverge. Since this one diverges, this one diverges. And again, I stress when I say you must perform the test correctly and show your work, that is what I mean. Perform the test and draw a conclusion. Okay, that was number 5. Number 8. It was the summation n equals 1 to infinity of 5n over 2 times the cube root of n to the 5th plus n. And looking at it right away, it looks rather messy. And I know if I'm going to do, say, the comparison test, I have to come up with something nice, probably by adding or subtracting. And frankly, just looking at it, I have no idea what I would add or subtract to it to make it either bigger or smaller. So I'm just going to forget that, and I'm going to think limit comparison, which means I need something to compare it to and to give me an idea of whether I think it'll converge or diverge. And we use the same type of trick. On top, what dominates? The n. I don't even need to worry about the 5. The n dominates. On bottom, what dominates? The 2 is irrelevant. This is a cube root, but inside I have n to the 5th and n. N to the 5th will dominate that, and then it will be cube rooted. So that's n to the 5th cube rooted, n to the 5/3. So overall, if I then simplify this, that's n to the 3/3 over n to the 5/3, which is 1 over n to the 2/3. Now, this is the one I will use for my limit comparison test. And if I look at this, well, that's just a p series. P is 2/3 less than 1, which means this one will diverge. So now I should assume, or at least it makes sense, that this will diverge, but now I'll actually do the limit comparison test and see that. So this will be one series, this will be the other, and I will get the limit as n approaches infinity of 5n over 2 times the cube root of n to the 5th plus n over 1 over n to the 2/3. Now again, this flips to the bottom, that flips to the top, and I get 5n times n to the 2/3 is n to the 5/3 over 2 cube root of n to the 5th plus n. Now I need to know what that limit is, and again we can use different tricks, but we'll rely on the same trick here, find the highest power of n, which is n to the 5/3. So I will divide each term by n to the 5/3. And I get 5n to the 5/3 over n to the 5/3. Now keep in mind on the bottom, this is just one term, so it'll be 2, the cube root of n to the 5th plus n over n to the 5/3. Now, on top, those will cancel. On the bottom, I'm going to have to manipulate this. Again, the 2 is a constant that will carry along. N to the 5/3, I'm going to bring inside this cube root. And it will become, if I go over here, on the top, we just have a 5. On the bottom, we have a 2. Here, if I bring this cube root inside that cube root, I'll get n to the 5th plus n over n to the 5th, all of that cube rooted. But now inside here, I'm going to run out of room. This is 2 terms over 1 term, so I can separate it as n to the 5th over n to the 5th plus n over n to the 5th, all to the 1/3. But then n over n to the 5th, as n approaches infinity, that goes to 0. N to the 5th over n to the 5th is just 1. And this becomes 5 over 2 times 1 to the 1/3. But that cube root of 1 is just 1. So I get 5 halves. The limit exists, it's greater than 0, and it's finite, which means both converge or both diverge. Since this one diverges, this one diverges. And then one more. Let's see, the last one was number 9, which was the summation from 1 to infinity of n over n plus 1 to the 5 halves. And again, here I'm going to probably go with the limit comparison test because the bottom is raised to a power, so adding and subtracting is probably not going to be incredibly easy for me. So first I really want to figure out what dominates this to see if I can figure out what other series to compare it to. On the top I just have n. On the bottom, again, the plus 1 doesn't matter, so ultimately that's an n to the 5 halves, which then becomes 1 over n to the 3 halves. That's a p-series where p is greater than 1, which means this one is convergent, which should lead me to believe that that series will be convergent. Now I do the test to see. So I set up my limit of that, n over n plus 1 to the 5 halves, over that, right there, 1 over n to the 3 halves. Again, everything flips, n to the 3 halves goes on top, and n times n to the 3 halves is n to the 5 halves over n plus 1 to the 5 halves. Now I can rewrite the whole thing as n over n plus 1 to the 5 halves. But now we know if I want, I can divide everything here by 1 over n, or I'm sorry, by n, divide by n, so multiply by 1 over n, however you want to say it. And I'll get n over n plus 1 over n, all raised to the 5 halves, which is just 1 over 1 plus 1 over n is 0 to the 5 halves, which is just 1 to the 5 halves, which is 1, which is again a constant greater than 0, it's finite, which means both converge or both diverge. This one converges, so this one converges. And like I said, as far as it goes, this is what I'm looking for. Look at the series. You should, to a certain extent, with a little bit of practice, be able to look at something and say, oh, that's convergent. Because I understand it's kind of sort of like a p-series with a p greater than 1, so it should converge. But then what you actually have to do is show the test out correctly that shows it's convergent. Oh, I'm doing the limit comparison test. This is what I'm going to compare it to. Do the whole test. Do the algebra. Find the limit. Oh, this is a k greater than 0. It's finite. So both of them converge or both diverge. P-series convergent, so that convergent. And ultimately, the hope would be that you understand the test well enough that when you look at a problem, you only have to perform one test and then you get your answer. Other times, if they're more confusing, you may end up getting to the end here and getting inconclusive, and then you just have to go through the whole thing again using a different test. But you have to show the entire test out in order for the problem to be correct. If there are any other questions from other homework problems or whatever, feel free to let me know and I'll just make more videos going through these.